So, as I said, welcome to INFS 1101. This is a sort of an introductory course to how we do problem solving in computing. And you might look at that and say, oh, that's going to be programming. And you may then you may ask me, oh, well, what programming language are we going to use? Actually, we won't be doing programming as such. The idea is for you to yourself imagine the limitations of a computer, because computers are not like people exactly. What we try to do with computers is we try to make them approximate some of the things that people do. And I say some of the things because whenever we get a little bit too hubris or too proud of what we've done with computers, we tend to be knocked back into our space to remind us that there's a lot of stuff about the way humans behave that is kind of hard to calibrate. But so what we try and do is we try and focus in on some simpler things, step-by-step things that a human might do in a situation which usually requires something to do with numbers or something like that, or pulling out records from a database. These type of things can be very step-by-step set out. And we as human will try and look at how we do that. Now, that might sound like, well, just get the computer to do it. Yes, but before we can get the computer to do it, somebody has to instruct the computer in how to do that simple thing. And so I hope that you understand what I'm trying to say here is that before we can give the computer those instructions, we have to kind of understand how we do our problem solving, and we have to make it very standardized. We have to have a standardized way of solving problems that we can then apply to some computerized device. Now, I was going to give you an example of how we think that we got it working and then it doesn't. Some companies like Google and Tesla, etc., made a big effort to get what they called autonomous cars. And autonomous cars, the idea is that they have a lot of sensors on them, and those sensors then are processing from the sensors, like 500 times a second. This type of huge amount of data is then going into a processor, which then is used to control the car instead of a human operator. And everybody thought that's a great idea and we're going to do this, but you notice that you don't see these cars now. 5 years ago, everybody was talking about it. And I'm not sure if you're familiar with the news item that sort of put that on the back foot, but what happened was that an autonomous car, I believe it was in the United States, Google was trying to do Google taxis or something like this, or Uber was doing, it was one of these companies, but it actually ran over and badly injured and possibly killed a cyclist. And so the problem there was that, okay, so there's lots of stuff that they did understand about how human drivers work in a car, but there was some aspects that they hadn't put enough effort into. And that was actually on how we see. And you might say, well, that's not so difficult a thing. You just put some sensors there, like a video recorder or something like that, and you see. But obviously, the sensors that were picking up the vision were not able to discriminate or tell the difference between a cyclist on a bicycle and other background things like poles or whatever. And the cyclist, of course, was moving. And so that sort of set that back. So I suppose we will eventually see autonomous cars, but they have a lot of sort of issues to sort of work through before that happens. So what we're going to do in this course, we're not going to be making autonomous cars or anything like that, but what we're going to be doing is trying to train ourselves. What I hope that you have at the end of this is that you can sort of remove some of the, I was going to say dumb yourself down. Now, that doesn't sound right, does it? What I mean to say is that you're able to think in a very constricted way, in a way that a computer would, because a computer cannot do all the things that you can do, not yet. And so there's some of the things that you can do that you just have to put them aside and say, look, I'm not going to do that at the moment. I'm just going to do this very, very simple sort of processing. And that way I will behave like a computer. And if I can do that, then I will be better at instructing the computer on what I want it to do. And so I'll get the results that I want from the computer because I'm able to work within sort of limited rules. And so we have some tools to help us to do that. And so, for example, we use pseudocode, and I will be introducing you to pseudocode in this course. Pseudocode is basically, it's like a programming language, except it doesn't run on any computer. It's like programming language for people. And so we just write in sort of English-like, and we just have instructions. Instructions could be like read from file, update, record. It could be add X to Y, Z takes the value of X plus Y, this type of thing. By just doing, writing pseudocode, we can do all the things that we do in sort of basic, what we call third generation languages programming, which is we have one command after another, and the first command is processed first. We have iteration, which means that we can repeat a bunch of code, or maybe just an individual bit of code. And we have selection, where we can come to a point in a program and we can say, well, we're going to go do that, execute that bit of code, but we're not going to execute that bit of code, or the other way, depending on value of some state or some variables. And and the other thing is that we can write a little bit of code and put it into like, if you like a container, we'll say that that's going to be a function. And then that function can be called and executed at any time. Now that's, as I said, that's third generation programming. And that's kind of what we're going to focus on in this course. You should be aware that since the 1990s, there's been lots of other things happen in computing. And so that very limited range of things that we can do with a computer, that has got a bit bigger. We do have object-oriented programming, and that's where you'll find yourself. And artificial intelligence, big data. There's lots of sort of stuff that we've sort of gone beyond the 1980s computing. But mostly what we're going to be doing in this course is 1980s computing, which is a good start. I mean, it had to happen before we could do object-oriented programming, before we could do artificial intelligence, all right, big data, this type of thing, relational databases. Before we could do those things, we had to have this very step-by-step sort of concept and way of understanding stuff. Now, I've been talking for a lot, and I haven't heard anything from you. Can I ask you at this point, I've been talking a bit, is this familiar to you, these things, or is it all new? Or where do we stand on that? What's happening, folks? So I got my 3 students here. You can send something to me in chat, or you can talk to me. I appreciate either of those. What do you think? All new, never heard this before. Okay, familiar for some. All right, so I mean, that's kind of what I expect. What I mean is some people, depending on what you did in high school, right? And some people in high school have been writing programs, you know what I mean? And so they had this course, something like this, I suppose. But but some of you have not, and that's why we have to offer it. So that's good. Some of it is familiar. That's good. I'm not going to go into too much more today, and that's actually on the instructions from the college, because a lot of things have been sort of changed. And maybe I'll just talk about that for a minute, if you like. The college has decided, or well, it wasn't the college decided, between the Ministry of Education and the college management, It has been decided that this will be a university. And so we are offering degrees. And in fact, so the name of this course, INFS, is the number, I should say, the code for this course, INFS 1101. That's a university degree course. Okay, so it's at the very basic level, but so things will be a little bit different than if any of you were at the college here before. So all students are going to be transitioned to university courses. I believe there may be some earlier exit points, but yes, Waleed, you do have more than one instructor for this course. That's because the course is divided into two different aspects. That is that we have the lecture aspect, which we're doing now, and there's the lab aspect. And so you have an instructor that will take care of the lab part of the course for you. And that's just, yeah, we're very lucky that we're able to actually get some people to help us with the labs. And so that's going to go ahead. And that could be, now it could be that, all right, so when you say this course, if you look at the numbers, I think mine is section 27 and the lab course is section 28. And you had to sign up for both of them, and you signed up for both of them at the same time. So I think that's what's happened. To be fair, we haven't ever done this before at this college. So it's that's why this week is starting off very sort of slowly while we get everything sort of. Yes, my instructions have been from the college that this week is online, but next week I expect that. All right, so the Ministry of Education has told us 50%. So somehow we have to organize ourselves to 50% of students on campus at any time. And so, yeah, we'll be bringing students into class. And I have to work with some other teachers on that, instructors on that, but we have a very small class. There's a number of ways that we could do that. There's probably some students that will have some exemptions because of some COVID related things maybe, but so we can work with that. The other thing you should know is that all major assessments, like anything around the 30% mark, 20% mark, are going to be on the campus. So we'll be online and on campus. Assessments will all be on campus. We're going to be trying to get students into classrooms. You'll see, if you look at your timetable, that we have a classroom assigned for this course. That's 10-134. And so there's enough room in there to probably fit most of us in there. But there's only 3 of you attending this class at the moment. There's only 5 students enrolled at the moment. And I expect that's going to change. I expect we'll have a lot more. So that's why we're sort of taking it slow at the moment. You know, and really, I'm just sort of introducing you to the class and to myself. Yeah, but very good questions. Any other questions like that? So you will be online this week. After that, will change. All your assessments will not, major assessments will be on campus, unless you have a special exemption. You do have other instructor because you have a lab component. So you might say, oh, lab component, but you just told us we're not going to be doing computing or computer programming. That's right, you won't be writing computer programs on a Python or Java or anything like that. What you'll be doing is writing pseudocode and other models. So we can still have a lab because you come to the lab and you write it there. I mean, you could use a word processor or you could use a pen and pencil. Any other sort of questions like that? Do you mind to tell me about yourselves, students? Is this any of you, this is your first semester at the college? So I asked before, did I teach you before? So 2 questions there that are related. Is this your first semester? And did I teach you before? I'm going to turn off the recording so that